recording for geometry, and this is hints for homework 3. Yesterday we did an activity with quite a few of the problems, and now we're just going to kind of look at some of the other problems. I'm going to give you hints and then some time to work on homework 3. When you get done with homework 3, you're going to work on homework 3A, which will be due as the schedule states. So we looked at a bunch of these. Now we're going to look at numbers 9 and 10, and I'm just going to give you a hint or two on this one. So step 1 is to graph the two triangles. And then you want to know, determine whether triangle MNO is congruent to triangle RS or QRS, and you're going to explain that using rigid motions. So you're deciding if they're congruent in your mind or if they look congruent, and you're going to give the rigid motions. So turn, slide, flip, or rotation, translation, and reflection. So whatever of that you're going to be able to pick. And then if they are going to be congruent, you also want to show the distances using the distance formula. And so you're going to find MN and then NO. Maybe I'll leave a little more space here. And then NO. These are the distances. And then OM. And just a reminder that the distance formula is the square root of parentheses x2 minus x1 in parentheses squared plus parentheses y2 minus y1 in parentheses squared. And the ordered pairs are x1, y1, and x2, y2. And then the matching sides, if MN is here, then QR should be the same as you go. And then NO, you're going to use RS. And then OM, you're going to use SQ. So you have to show that those either are or are not the same. And if they are, you're going to be using side, side, side congruence. I'm not going to write all that on this next one. You're going to do the exact same thing. Graph them, distance formula, same letters, so same lengths of sides, and then kind of move on through that. Number 12 we talked about yesterday, hopefully, and so we'll leave that one. Then number 13. I'd like to kind of just go over some things with you and just give you some hints in this. So we know R is the midpoint of segment QS and segment PT. If you're in the room, I'm going to ask you to point on your key terms page to where that is. And then I'm also going to ask some students to think about telling, or to be able to tell me what segments have to be the same. So let's say R is the midpoint of segment QS first. So I'm going to ask somebody to tell me what those are. Then think about the midpoint. R is the midpoint of segment PT. So tell me what has to be congruent from that midpoint. And hopefully people told me that QS is right here. If R is the midpoint, then this little piece and this little piece are the same. Likewise, PT, R is the midpoint of PT, so this little piece and that little piece are the same. If you haven't already, mark those. QR, segment QR is congruent to segment RS. Segment PR is congruent to segment RT. Look on your main key terms page and see if you can find another pair of things. And really, this is a lot like a proof that we wrote in the notes. So this should be helpful. And we should have found that there are vertical angles. So when we cross these, the vertical angles are right there. We know that we have to use 3 letters to name the vertical angles, and so I'll ask somebody to tell me what those are. And then think about what you're going to do to write this proof, or maybe I'll leave that there for a minute. And you're going to write yourself some hints or your plan. And so you should be using the midpoint theorem and the vertical angles theorem. And think about whether you're going to use side, side, side congruence or side angle side congruence. Look at how the picture is marked. And then I think you're ready to write your proof. So see what you can do with that one as we go. Then moving along, the next one has another proof, and it says to write a flow proof, but we know that we can write whatever proof we feel most comfortable with. And so let's look at this one as well. We'll pause this and I'm going to ask a bunch of questions and then I'll mark the picture by our results. So for this one, hopefully we've discussed some of these things, but look at the proof statement right away and notice that it's angle MJL, which is this angle right here, and angle KNL that we want to show are congruent. So there's a lot of triangles here, and we have to decide what 2 triangles we're going to be using as we look at this picture. So let's see what the pieces are that we know. We know segment JM, which is right here, is congruent to segment NK, so we can mark those. Let's do that. And we know L is the midpoint of 2 things, so we've had that before. L is the midpoint of JN, so that means here's JN, L is the midpoint, so these little pieces are the same. And likewise, let me just remark those. Likewise, L is the midpoint of segment KM. So here's segment KM. L is the midpoint. So these are the same as those. So I think that if I mark those parts, then I can get a lot of little triangles that are going to be congruent. And I'm going to use maybe a light orange color. I think if I look at this triangle right here and this triangle right here, that I've marked all 3 sides on this one, all 3 sides on that one. And so I could say those 2 triangles are congruent by what congruence, side, side, side congruence. And then once those are congruent, then we can use that CPCTC and say that their parts are congruent, and then we can get these angles. Remember, even if it doesn't say that the triangles are congruent, we know that we want to prove that the triangles are congruent and then use those parts as we go. I do have here, I think, the handout with things on it. And so what we're using here at the end is that CPCTC. Once we know that the 2 triangles are congruent, then we can say their parts are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So that's what we're going to use in this case. And so back to this problem, maybe it's this one. And so here's your strategy or your plan maybe as we go. So our plan is to use the given and the midpoint theorem. And then the triangles that we're going to have, I think we'll call them triangle MJL, congruent to, if I went from M to J to L, I think I want to go from K to N to L, because those will be marked the same. Let me just see if I can remark that real quick the way that we had it. I think like this. So if I go MJL, so MJL, I'm using the 1 mark side, then the 2 mark side. I have to go KNL, 1 mark side, 2 mark side, triangle KNL by, and that's always 3 letters congruence, either side, 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 or side angle side. Think about what that is. And then we're going to get the proof statement by CPCTC. So write yourself a little plan for that one, and then we'll move on. Pause this if you need to. Then moving on, the next one we know is an equilateral triangle. So actually just go to your notes right now and point to where we wrote something about equilateral triangles. I think it was the second key terms page. Find where that is. So, because this is a triangle that is equilateral, that whole big triangle, then we know all of these sides, this one, and that one, are congruent. Well, maybe we're just going to say that these two are congruent because of the equilateral triangle, because we really want to break this into 2 little triangles. So we've got this triangle here and this triangle here. So we don't want to use that side as a whole side. We want to use it as maybe 2 little pieces. And then we also know that segment WY bisects angle XYZ. Point to that on your main key terms page. So see if you can find that. And that is pre-marked on here, so it's a little hard for me to kind of remark it as we go. And while you're looking at that key terms page, see if you can find another thing, point to that for me, that would also be congruent as we go. So what we should have found is this one has, and maybe I'll go to that handout real quick. This one has first the, if we know ray AB bisects the big angle, then these 2 little angles are congruent, and that's the definition of an angle bisector. So hopefully that's what you picked first. And then we have a common side again on this picture. And so we can say segment AB is congruent to segment BC by reflexive, and that's going to be the common side. Just a note to self, since I'm looking at this page, I think we're going to use that CPCTC again as well. So let's kind of map out our plan here. So let's mark that common side. Think about whether we're going to use side-side-side congruence or side-angle-side congruence. And let's write our little plan here. So our plan is we're going to use that definition of an equilateral triangle. We're going to use that angle bisector. We're going to use that common side, which is really reflexive. We don't write it as the common side. We're going to use what congruence. Look at the picture for the triangles. Triangles congruent by what congruence. And then once we have that, these are parts. So then we're going to get our proof statement by CPCTC. And I'm going to ask somebody to tell me what that means as we go. So those are your hints for this problem. Pause this if you need to kind of write some things down from that. And then the only other problem in this homework is number 31. And for that one, you're just on your own. It asks you to kind of explain some things. So this concludes and I'm going to say what this was called. This concludes the hints for in class for homework 3. And tomorrow, this is due. And so we'll be kind of going over these proofs, and really for this section or this chapter, when you're writing all these proofs to do the homework grading, you need to correct the proofs. So you should end up with a bunch of handouts with correct proofs on them in the end. And that's what we'll be looking at for credit. So this concludes the hints. This is due tomorrow.